Welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're looking at using rules, tables, and graphs to explore linear relationships. So the word linear just means straight lines. So we're looking at relationships between two variables, x and y, where they form a straight line. By the end of this lesson, you'll be able to use a rule to construct a table of values, use the table of values to graph a straight line, and check to see if a point lies on a line or not. So let's have a look at the first part of this lesson, using a rule to construct a table of values. Now, the following are examples of rules. Okay, we've got y equals 2x, y equals x minus 1, y equals minus 4x plus 3, 9x plus 2y minus 8 equals 0, y equals x squared, y equals 4x cubed minus 7, y equals 1 over x, y equals 2 to the power of x. Now, when we're talking about linear relationships, we're talking about graphs of straight lines. And only the first four here, A, B, C, and D, will actually produce a straight line. E, F, G, and H, they are all non-linear curves. So we are only going to be focusing on these kinds of rules in this video. Okay, we are not going to be focusing on E, F, G, or H. You will learn about them later on. Now we can use these rules to make a table of values to help us sketch a graph. So let's have a look at some examples, constructing a table of values for these questions here. Y equals 2x. Now it's important for you to remember that 2x means 2 times x. So if I were to construct a table of values, let's say we've got x and y, and I want to go from minus 2, minus 1, 0, 1, and 2. Well, if x is minus 2, then y is equal to 2 times minus 2, which is minus 4. If x is minus 1 this time, then y is equal to 2 times minus 1, which is minus 2. If x is 0, we have 2 times 0, which is 0. If we have x is 1, we've got 2 times 1, which is 2. If x is 2, 2 times 2 is 4. Okay, so I want you to have a go with question B by yourselves. I'll create a table of values here for you. Minus 2, minus 1, 0, 1, and 2. I'll get you to pause the video and I'll get you to have a go completing this one yourselves. Okay, so here's my answer. When x is minus 2, y is minus 6. When x is minus 1, y is minus 3. When x is 0, y is 0. When x is 1, y is 3. And when x is 2, y is 6. Right, let's have a look at question C. We're going to construct our table of values, x and y. Yep. I like to go from minus 2 to 2. So if x is minus 2, then y is minus 2 minus 1. And minus 2 minus 1 is minus 3. But what if x was minus 1? If x was minus 1, then y would equal to minus 1 minus 1, which is minus 2. If x was 0, y is equal to 0 minus 1, which is minus 1. If x was 1, y is 0. If x is 2, y is 1. Okay, let's do the same thing for question D. X and y. 1, 2, 3, and 4. Minus 2, minus 1, 0, 1, and 2. I'll get you to pause the video and have a go with this yourself. Okay, here are my answers. Please check them with yours. Right, question E. X and y. 1, 2, 3, and 4. Minus 2, minus 1, 0, 1, and 2. So if x is minus 2, y is equal to minus 4 times minus 2 plus 3. Well, minus 4 times minus 2 is positive 8. And positive 8 plus 3 is 11. What if x was minus 1? If we were to replace that with minus 1 instead, we've got minus 4 times minus 1, that's positive 4. And 4 plus 3 is 7. What if we were to replace x with 0? Minus 4 times 0 is 0, plus 3 is 3. If we were to replace x with 1, according to this one, minus 4 times 1 is minus 4, plus 3, that's minus 1. If we replace x with 2, we have minus 4 times 2 is negative 8. Negative 8 plus 3, that's negative 5. Okay, pause the video and have a go with question F. Okay, so here are my answers for question F. Alright, let's have a look at part 2 of this lesson. Using a table of values to graph a straight line. So the whole point of knowing how to complete a table of values from a rule is so that we can sketch the straight lines. So here we've got sketched the following: y equals minus 4x plus 3. If we have our table of values, and we've already done this before, minus 4x plus 3 is up here, question E. So I'll just write them in: 11, 7, 3, minus 1, and minus 5. We are going to graph this where we can. So we don't have a y equals 11 here, it only goes up to 7. So I might start off with this one. When x is minus 1, y is 7, so it's just going to be a dot up there. So just remember how to write these coordinates. This one here, that's minus 1, 7. This one over here is 0, 3. The next one's 1, minus 1. And the next one's 2, minus 5. I mean, we can do this one as well, minus 2, 11, but there's no point because we can't actually graph that on what we're given here. So we have minus 1, 7. We have 0, 3. So we go 0 across up to 3. We have 1, minus 1. So across to 1, down to minus 1. And then we've got 2, minus 5. So we go across to 2, down minus 5. Remember, we always go across first and then up or down. And you'll notice that the 4 dots that I've plotted, if I were to connect those dots, it'll form a straight line. So you know that you've done it correctly. And I will put arrows on the endpoints of that. Okay, so use a ruler. I don't have one on me, but use a ruler and have a go with doing that. And the next thing I would probably do is also label this graph with the rule that that it was y equals minus 4x plus 3. Okay. Right, why don't you pause the video, have a go with question B by yourself. Now question B, we've got y equals 3x, which is up here, question B. So if you want to just copy down this table of values for that, you can, and then have a go with graphing it. Okay, so here is my table of values, and I've plotted these points. Points are minus 2, minus 6, minus 1, minus 3, 0, 0, 1, 3, and 2, 6. Okay, I've plotted those points, and then I've sketched my straight line. Alright, there are 2 more that I want you to have a go with. Actually, I'll do C with you, and then you can have a go with D. But what I want to show you here is, I know we've done 5 points here when x is minus 2, minus 1, 0, 1, and 2. But in reality, we only need 2 points. Once we've got 2 points, say for example this one and this one, we can plot those 2 points, and that's enough for us to be able to draw a straight line. Plot those 2 points, use your ruler, and then graph it. So that's exactly what I'm going to do with C here, and that's what I want you to have a go with doing for question D. So for question C, I'm going to create my table of values, but really we only need 2 points, and I always like to use 0 and 1, unless if there's a fraction in there. So for example, if the question said y equals 2 over 3x plus 7, then when I'm doing my table of values, I like to use 0 and the denominator, because that will give me a whole number instead of a fraction for y. And that's a lot easier to graph. Okay, but let's have a look at question C. When x is 0, y is equal to 0 minus 4, which is minus 4. And when x is 1, y is equal to 1 minus 4, which is minus 3. So we've got 2 points, 0 minus 4, and 1 minus 3. 0 minus 4 is down here. 1 minus 3 is over here. And that's enough. Okay. Now I can actually use my ruler and I can draw a straight line. I know it's going to go like that. Oops. Let's fix that bit. Right there. Draw my arrows and let's label it. Y is equal to x minus 4. Okay, pause the video, have a go with question D by yourself. Okay, here's my answer for question D. I've done my table of values using 0 and 1 for x. That gives me 2 points, 0 minus 1 and 1 minus 3. I'll plot those 2 points on the graph below. 0 minus 1, 1 minus 3, and that's enough for me to graph a straight line. So I grab my ruler, draw my straight line, and I label it with the rule above y equals minus 2x minus 1. Make sure you draw your arrows on both ends, because this line goes on forever in both directions. Okay, let's have a look at the last part of this lesson, which is determining if a point lies on a line or not. So to determine if a point lies on a line or not, what we need to do is substitute the x and y coordinates from the point into the rule and see if the left-hand side, LHS, equals the right-hand side, or RHS. So what do I mean by that? I mean, here is my x value and here's my y value. Remember, it's always x and then y. So I'm going to sub those values into the rule. So you see here how it says y? I'm going to replace it with 4 because that's what y is. 4 is equal to, I've got an x here, I'm going to replace it with 3 because that's what x is. 3 plus 1. Oops. Is that true? Is 4 equal to 4? Yes, left hand side equals right hand side. So we can say, therefore, 3, 4 does lie on the line y equals x plus 1. If left hand side did not equal to right hand side, then we conclude that that point does not lie on that line. Let me go through one more with you and then you can have a go at questions C and D. Does the point minus 2, 5 lie on the line y equals minus 2x minus 1? I'm going to replace y with 5. We've got minus 2 times x. I'm going to replace x with minus 2 minus 1. Okay, so we need to work out what the right hand side is equal to. We have minus 2 times minus 2, which is 4, positive 4, minus 1. That's 5 is equal to 3. So we can see that the left-hand side does not equal to the right-hand side. They're not the same. So now we can conclude, therefore, minus 2, 5 does not lie on the line y equals minus 2x minus 1. Okay, I want you to have a go with question C and D by yourselves. Pause the video, and when you're ready to check your answers, continue playing it. Okay, here are my answers for questions C and D. For question C, we substitute minus 2 for x and 4 for y. We can see that 4 is equal to minus 6. That's not right. The left-hand side does not equal to the right-hand side. So we can conclude that minus 2, 4 does not lie on that line y equals 3x. Question D, we can substitute y as minus 2 where y is, and minus 3 where x is. So minus 2 is equal to minus 3, minus 5. Minus 2 is therefore equal to positive 3 minus 5. We've got minus 3 is positive 3, and 3 minus 5 is minus 2. So we can see that the left-hand side does equal to the right-hand side, and therefore we can conclude that minus 3 minus 2 does lie on the line y equals minus x minus 5. Now you might be wondering, what does this all mean? What do you mean by does it lie on the line or not? Let's go back to question A, for example. If I were to graph this, okay, if I were to graph y equals x plus 1, let's say that's 1, that's 1, 2. If I were to construct a table of values, I will know when x is 0, y is 1, when x is 1, y is 2, right? And then I can graph my straight line. Okay, I can graph a straight line. Well, what we're saying here is, if I were to graph 3, 4, 2, 3, and extend this one, this would actually be 4. 3, 4 does lie on that line. Okay, however, if the question said 3, 5, oh, actually, let's not do 3, 5, let's do 3, 3. 3, 3 is over here, and we can see that it doesn't lie on the line. But 3, 4 does. And that's all we're doing for all of these questions, A, B, C, and D. Does it lie on those lines? When we graph them, will those points lie on those lines or not? Yes or no? Okay, so that's it for this video. Now you know how to construct a table of values and use it to graph straight lines, as well as to determine whether a point lies on a line or not. Thanks.